Hello all and welcome to my YouTube video. My name is Dada Peer from Sri Venkateswara College of Engineering. In this video, I will be discussing load balancing in cloud computing. We will cover what is load balancing, why it's important and how it is used in cloud computing. We also explore some of the challenges associated with load balancing and discuss some of the tools and techniques used to address those challenges. I am excited to share my knowledge with you and I hope that you will find this video informative and helpful. So without further delay, let's get started. In this video, we shall go through the following contents. Introduction, goals of load balancing, importance of load balancing in cloud computing, comparison between traditional and cloud-based balancing, working of load balancing, activities involved in load balancing, examples of cloud load balancing services, load balancing algorithms, and types of load balancing. Load balancing strategies for cloud applications, load balancing tools, activities involved in load balancing, impact of load balancing on latest technologies, and conclusion. Let's move to introduction. In the context of cloud computing, load balancing is the process of dividing workloads among a variety of computing resources, such as servers, storage, and network equipment, in order to maximize resource usage, reduce downtime, and guarantee the high availability and scalability of software and services. The widespread use of the internet and the World Wide Web over the past few years has considerably changed how we work and live. With the aid of cloud computing, it is possible to work in a setting that is much more straightforward and practical, as well as with comfort and trust. Today, cloud computing is used in many fields, such as image cryptography, virtualization, finance and e-commerce, the Internet of Things, deep learning, resource optimization, and such computing. Load balancing can be achieved through various techniques, such as at round-robin, weighted round-robin, least connections, IP hash, and least response time. These techniques use algorithms to distribute incoming traffic across multiple resources based on various factors such as resource availability, traffic volume, and resource capacity. Load balancing is the process of improving the performance of a parallel and distributed system through a redistribution of load among the processes. A basic example of load balancing in our daily life can be related to websites. And next we are discussing goals of load balancing. First one is application response time. Application response time in load balancing in cloud computing refers to the time it takes for an application to respond to a user request after the request has been received by the load balancer. And second one is efficient availability of application. Efficient availability of applications in load balancing in cloud computing refers to the ability of load balancer to ensure high availability and reliability of applications by efficiently distributing traffic across multiple servers or resources. Third one is user location. User location is an important consideration in load balancing. When a user requests access to an application or service hosted in the cloud, the request is typically routed through the internet and the response is returned to the user through the same path. Fourth one is time of day. Time of day is another important consideration in load balancing. In cloud computing, the load on application and services can vary significantly depending on the time of day, with peak traffic occurring during certain periods such as business hours or peak shopping period. And lastly, the current and total capacity of data centers hosting applications is a critical consideration in load balancing. Load balancers must be able to monitor the capacity of each data center and distribute traffic accordingly to ensure that the application remains responsive and available. Now we are discussing importance of load balancing in cloud computing. Load balancing refers to the process of distributing network traffic across multiple servers or resources to ensure that no single resources becomes or fail. The advantages of load balancing include increased scalability, improved reliability and availability, better performance, enhanced security, cost savings, and overall load balancing is an essential tool for any organization that wants to achieve the availability, reliability, and performance of their application. And next we are discussing comparison between traditional load balancing and cloud-based load balancing. Traditional load balancing typically involves hardware-based solutions, such as application delivery controls that are deployed on premises in a data center or a network edge. In contrast, cloud-based load balancing leverages the scalability and flexibility of cloud computing to distribute traffic across virtualized resources such as virtual machines, containers, or serverless functions that are provisioned and managed by a cloud provider. Here are some key differences between traditional load balancing and cloud-based load balancing, which includes security, flexibility, management, and cost. Overall, cloud-based load balancing offers greater scalability, flexibility, and cost effectiveness than traditional load balancing. However, traditional load balancing may still be preferred in some cases, such as when there are strict regulatory requirements or when applications require low latency and high performance. Next, we are discussing working of load balancing. The load balancer uses a predetermined pattern known as load balancing algorithm or method. This ensures no one server has to handle more traffic than it can process. Different algorithms manage the process using different techniques. You therefore have multiple options to choose from when making a decision on what type of load balancer to use. Here are the basics of how a load balancer works. A client such as application or browser receives a request and tries to connect with a server. A load balancer receives the request and based on the present patterns of the algorithm, it routes the request to one of the servers in a server group. The server receives the connection request and responds to the client via the load balancer. The load balancer receives the response and matches the IP of the client with that of the selected server. It then forwards the packet with the response. Where applicable, the load balancer handles SSL offload, which is the process of decrypting data using the security socket layer encryption protocol so that servers don't have to do it. The process repeats until the session is over. Next, we are discussing activities involved in load balancing, scheduling and allocating tasks to VMs based on their requirements constitute the cloud computing workload. The load balancing process involves the following activities. The first one is identification of user task requirements. Second one is identification of resource details of a VM. Third one is task scheduling. Fourth one is resource allocation. And fifth one is migration. Next, we are discussing examples of cloud load balancing services. The following are some examples of load balancing solutions offered by different cloud providers. There are 4 load balancing services provided by Microsoft Azure for distributing services throughout several Azure regions worldwide. Azure Traffic Manager is a layer 7 DNS based traffic load balancer. A layer 4 network load balancer for relaying traffic across VMs is Azure Load Balancer. A layer 7 delivery control for regional application is Azure Application Gateway. And second one is Elastic Load Balancing from Amazon Web Services. Distributes incoming client traffic and directs it to registered targets like EC2 instance. Next, we are discussing load balancing algorithms. A load balancing algorithm is a set of rules that a load balancer follows to determine the best server for each of the different client requests. Load balancing algorithms fall into 2 main categories, and first one is static load balancing and second one is dynamic load balancing. First one is static load balancing. Static load balancing algorithm followed fixed rules are independent of the current server state. The following are examples of static load balancing: round robin method and wait round robin method and IP hash method. Second one is dynamic load balancing. Dynamic load balancing algorithm examine the current state of the server before distributing traffic. The following are some examples of dynamic load balancing algorithm. First one is least connection method, second one is wait least connection method, third one is least response time method, and fourth one is resource based method. Next, we are discussing types of load balancing. There are several types of load balancing techniques used in cloud computing. Here are some of the common types. First one is network-based load balancing. Second one is DNS-based load balancing. Third one is application-based load balancing. Fourth one is server-initiated load balancing. Fifth one is client-initiated load balancing. And finally, hybrid load balancing. These load balancing techniques are designed to ensure optimal resources utilization, high availability, and scalability in cloud computing environments. Next, we are discussing types of load balancing technologies. Load balancing technologies can be classified into three categories: hardware based and software based, and virtual load balancers. Both hardware based and software based load balancing technologies can provide essential load balancing services, including traffic distribution, failover, session persistence, SSL offloading, and software-based load balancers depends on the organization's requirements for performance, scalability, reliability, and budget. Next, we are discussing load balancing strategies for cloud applications. Load balancing is an essential strategy for ensuring that cloud applications are highly available, scalable, and performance. Here are some load balancing strategies that are commonly used for cloud applications. First one is horizontal scaling, second one is vertical scaling, third one is session persistence, fourth one is health monitoring. Fifth one is load balancing across multiple data centers or regions. Sixth one is load balancing for specific workloads. By implementing these load balancing strategies, cloud applications can more be resilient, scalable, and responsive to the changing user demand. Now we are discussing load balancing tools. There are several load balancing tools available in the market, each with its own unique features and capabilities. Some popular load balancing tools include HA Proxy and F5 Big IP and Apache HTTP Server and Microsoft Azure Load Balancer. Next, we are discussing load balancing challenges. While load balancing offers many advantages, it also comes with some challenges that must be addressed to ensure its effectiveness. Some common load balancing challenges include: first one is configuration complexity, second one is scalability limitation, third one is single point of failure, fourth one is security risk, and fifth one is monitoring and troubleshoot. Next, we are discussing impact of load balancing in latest technologies. Load balancing plays a crucial role in enabling the latest technologies and ensuring their effectiveness. Here are some examples of how load balancing is helping in the latest technologies. First one is cloud computing. Load balancing is essential in cloud computing, where virtual servers and resources are dynamically allocated and deallocated. Second one is Internet of Things. IoT devices generate massive amounts of data that need to be processed and analyzed in real time. Load balancing can help to distribute traffic across multiple servers or cloud resources, ensuring that the data is processed quickly and efficiently. Third one is microservices. Microservices are a popular architecture for building large and complex applications. Load balancing is crucial in microservices where different components of an application may be distributed across multiple servers or containers. Fourth one is artificial intelligence and machine learning. AI and ML require significant processing power and resources. Load balancing can help to distribute the processing load across multiple servers or cloud resources, ensuring that the algorithms can be trained and run efficiently. Fifth one is containers. Containers are lightweighted and portable virtual environments that can be quickly developed, deployed, and scaled. Load balancing helps to distribute traffic across multiple container instances, ensuring that each instance can handle the traffic it receives. Finally, conclusion is load balancing spreads traffic and workloads to prevent any server or computer from being overloaded or sitting idle. To improve the effectiveness and durability of cloud application, load balancing in cloud computing evenly distributes traffic and computing resources throughout a cloud environment. Relational database requires server load adjusting where worldwide servers require it for investigation across various areas and DNS load adjusting for domain name working. The availability of cloud services, resource planning, QoS management, energy consumption, and performance monitoring are some challenges associated with cloud load balancing. These are the references for load balancing in cloud computing.